Now see here average power associated with capacitor only. So the AC circuit containing capacitor here, so we have to calculate power associated with this circuit or the power consumed by the circuit. We know EMF at any instant is equal to E naught sin omega t, and current at any instant we have already calculated, that is I naught sin omega t plus pi upon 2, that is a phase difference of 90 degree. Current is ahead. So we can write I naught cos omega t also. So now the power consumed at any instant is power is equal to E into I, that is instantaneous power, and that can be written here, power is equal to E naught sin omega t and I naught cos omega t. So we can write here dW upon dt, that is the rate of consuming power here, energy, E naught I naught divided by 2, that can be written sin 2 omega t. So I have multiplied by the 2 and divided by 2. So it will be converting into the sin 2 omega t. Now we can calculate the total energy consumed in one cycle, that is here dW is equal to E naught I naught upon 2 sin 2 omega t into here, that is dt. So now we can calculate from here. So we can integrate it. So when we integrate, we will be getting integration of this dW is equal to here E naught I naught upon 2, and this is 0 to t, we will be getting sin 2 omega t dt. So when we integrate it, so we get the 0 this value, that means the average value of sin 2 omega t is equal to 0. So it means you will be getting the total work done in one cycle or the total energy consumed in one cycle, that will be equal to 0. So W is equal to 0. Then average power you can get, average power is equal to also here the W by T, that is the total energy consumed in one cycle divided by total time taken, and that will be equal to here 0. So in capacitor is also here, that is the only pure capacitor, there is no resistance at all in the circuit, then the average power consumed by this circuit is equal to 0.